For number 4, we have a free body diagram and motion of a ball on a string. Looks like all the pictures came through on the PDF, so we should be in good shape here. A heavy ball swings at the end of a string as shown above with negligible air resistance. Point P is the lowest point reached by the ball in its motion, and point Q is one of the 2 high points. So for part A, we're going to draw a free body diagram for, we're drawing vectors that could represent the velocity and acceleration of the ball at points P and Q. If the vector is 0, we need to explicitly state that. So we're going to start for point P, which is the very lowest point in the trajectory. So at point P, the ball is moving to the right, so the velocity vector goes to the right. Since we're moving in a circle, the acceleration and net force are towards the center. So we get a point for the horizontal vector. The rubric says right or left, although pretty clearly it's moving to the right, but that's okay. 1 point for the acceleration vector pointing up. All right, that's point P. What about at point Q? Now we're at the top of the string. And what happens for an instant at the top of the string? Well, the velocity is equal to 0. So we need to explicitly state that. Now there's 2 forces acting on the ball at this point. Gravity is pulling straight down and the tension is pulling towards the center. The resultant vector then is something like this. It's something third quadrant E. That's your acceleration vector, okay? That's your acceleration vector. So rubric for this one, you get 1 point for indicating that the velocity vector is 0, and you get 2 points for the acceleration vector being perpendicular to the string, okay? Perpendicular to, the string that's the tension force here. So 3 points total there. They did say that you could get 1 point if you got acceleration in the right quadrant, but if your angle wasn't quite right, if there was no perpendicular angle here. Now, I don't know if you need to actually draw that right angle to get that point or not, but that's the way the correct answer goes. So that's part A. Now, part B asks you, after several swings, the string breaks. The mass of the string and air resistance are negligible. Now we're going to sketch the path of the ball if it breaks at P or if it breaks at Q. So if the string breaks at P, the ball is going to keep going in a horizontal line, but then eventually it's going to be a projectile. So it's going to be parabolic. Now it does say sketch. Yeah, sketch the path. So if this were me, I would scribble the words initially horizontal, then a parabola. If you're not confident in your drawing, actually, you're not going to have to draw it. So if they might say, discuss it. So we want to say initially it's going to go horizontally because that's the direction it was going when the string broke. Then it's going to become a projectile and its trajectory will be parabolic. So 3 points on this rubric. 1 for indicating it'd be initially horizontal. 1 point for constant horizontal motion. So in other words, not something like that. And then 1 point for vertical motion due to free fall. So 3 points for that one. Now, what if it breaks at Q? Okay, if it breaks at Q, it's stopped, right? It has stopped momentarily. So what's it going to do? Straight down. That one I had to think about it for a little bit, but that's the trajectory. If it stops there at the top of its arc, it's just going to go straight down. So we get, the rubric says 1 point for drawing a line that's straight down, 1 point for indicating that it's in free fall or under constant acceleration. Now, it does say briefly describe the motion of the ball. So I guess we sketch the path and briefly describe. So that would be my brief description, starting from rest and then accelerating at 9.8 meters per second. So that's it for this one. No paragraph there, but certainly a couple of short answers.